greatest integer function. Sometimes we call this a step function. Greatest integer function is not widely used, it's not super popular, but it is good to know what it is. So there are two ways to write it. The textbook that I read, they used a double square bracket. So f of x, right here, f of x is equals to, we have x, and then for the greatest integer, the symbol that the textbook I use, they use a double square bracket. So this double square bracket, one on the left side, one on the right side, and then I also look up online. Sometimes people use one square bracket, sometimes people use two square bracket. Depends on what textbook you use. I think just stick with the preference of the book. If your textbook use two, then use two. If your textbook use one, then use one. Okay, so in this video, I show you two ways to sketch the graph of the greatest integer function. The first one that I show is using decimal. So this one, using decimals. Desmos is a free graphing calculator app. You can download this to your phone, or you can use your computer. Just look it up on Google. You can do it on your computer as well. So the way what you have to type is, you have to type here. Do you see this? You have to type y is equals to floor x. I don't know why they named that floor, but it's programming stuff. So floor x, and then they also show you f of x equals to x. They show you the table value. So when x is equals to -5, y is equals to -5. When x is equals to -2, y is equals to -2. They might be saying, okay, so I just look through the table. It looks like whatever x equals to, y just equals to that. Okay, so let's take a look at the graph. So take a look at the graph. It looks like a staircase, right? Steps. So step function. It looks like a step. So let's take a look at let's pick a piece to take a look at. Let's pick this piece. All right. So we have from 0, right? So this is a 0. And then this is a 1, right? So when x is between 0 and 1, including 0, but not including 1, y is equals to 0. When x is between 1 and 2, including 1, not including 2, y is just equals to 1. And then this piece, when x is equals between 2 and 3, and then y is just equals to 3. So how is that going to work out? The greatest integer function, right? So I gave you some examples over here. So let's take a look. When f of 2 is just equals to 2, so we have this point. When x is equals to 2, y is equals to 2. But if you plug in something like that, 2.1, 2.579, so you are putting numbers right here. Do you see that? Right here, I am talking about this piece. So if you plug in some decimals like 2.1, 2.5, 2.009, so you have numbers right here, the corresponding y value is all equal to 2. So as long as you don't reach to 3, the corresponding y value is equals to 2. Do you see that? 2.1, 2.579, and then 2 point a bunch of 9. So all of the corresponding y values are equals to 2. But once you reach to 3, then it will just equals to 3. So if you go back to the graph, once you reach to 3, you will just get here. When x is equals to 3, y is equals to 3, because the greatest integer. So think about this. You are standing at 2. So let's say you are standing up right now. Okay, so you are standing up straight, and then your foot is stepping on a 2. Just picture this in your mind. You are standing up, or you can do it right now. Stand up, look forward, okay, and then look down. Just imagine that your shoes is stepping on a 2. Okay, so x is equals to 2. So between 2 and 3, imagine that in some distance, like ahead of you, there is a 3. So as long as you don't step on the 3, as long as you are walking between your current steps and without touching the 3, so you are stepping forward a little bit, and then you are keeps trying different places. So you make 1 step, 2 step, 3 step. Just don't touch the 3. As long as you are not stepping on the 3, y is still equals to 2. Another way to think about this is, as long as you do not step on 3, so every time you take a little step forward, 2.1, 2.01, 2.9090, you will just bounce back to a 2. Again, you are taking a step, 2.511, you step forward, and then it will just bounce you back to a 2. All right, just like playing a video game, it will just bounce you back to a 2. But once you step at a 3, you are at 3. Like you are at the next step. Once you step at 3, but if you pick something like x equals to 3.001, you take a extremely small step forward, it will bounce you back to a 3. So that means for a step function, so if you picture this as a staircase, as long as this is 2, right? So the entire step is x equals to 2, right? So this in here, the entire step, oh sorry, not x equals to 2, is y equals to 2, right? So as long as your foot is not on the next step, so as long as your foot is not touching the next step, you are still at 2. All right, so just like walking up on a staircase, as long as you are not touching the next step, you are still at 2. Okay, so let's take a look at the other screenshot, like right over here. So this one, I show you how to graph that using a TI84 plus graphing calculator. So the place that you will have to go is first, you will have to press the y equal key. Do you see that? Y equal key, and then make sure there is nothing. Just go up and down, make sure there is no other function typed in, and then you will have to press the math key. So you press the math key, and then you go to num, N-U-M, just press the right arrow, go to num, and then select int, integer. So once you select int, click enter, and then type x. X is right next to the alpha key, the green key, right next to alpha. And then you close the interval, hit graph. The downside of using a graphing calculator is they don't show you the open circle. In case you might be wondering, hey, how come there is an open circle in every step, like at the tail of every step? So here is, do you still remember the vertical line test? Have you heard about the vertical line test? Every function must satisfy the one-to-one property. If I draw a vertical line like that, the vertical line should have one intersection only. So I have one intersection right over here. If I use an closed circle, then I will have 2 intersections. That means this is not a function. So therefore, you will have to close this. You have to end this with an open circle. If you end that with a solid circle, then the one-to-one property is not satisfied. But the graphing calculator doesn't show you this. So that's why for this function, I prefer you to graph that or look at that, study that using Desmos. It's free anyway. Alright, so that is the end of this video. If you like it, give me a thumbs up, a subscribe. Truly appreciate your subscription, and I will meet you all in the next video. Take care.